All right, everybody, welcome to the video here for the homework assignments for lessons 4 and 5. So for lesson number 4, the first homework assignment came out looking like this. Now this picture we've actually seen before, but we're actually going to do some different proof stuff with it. So the first thing it tells us is that this is a parallelogram. So knowing that it's a parallelogram tells us that we have 5 things that are true about this shape. It also tells us that FG bisects DB. Well, that tells us that DB is getting cut in half. So I'm actually going to say that these two segments here and here are the same size. And then it wants us to prove that FE is congruent to EG. This tells us I'm going to use CPCTC for my proof. So let's jump into this one. So the first thing it says is ABCD is a parallelogram. That's given. Well, if I know that's a parallelogram, I know a lot of different things, but which one do I want to actually use here? So what I want to use is alternate interior angles coming from the parallel lines CD and AB. So I'm going to say that CD is parallel to AB. I know that because in a parallelogram, opposite sides are congruent. Not congruent, parallel, sorry. So if I know those sides are parallel to each other, I know these interior angles, 1 and 2, are going to be congruent. So I could say that here as well. So I'm going to say angle 1 is congruent to angle 2 because of alternate interior angles. Now the next thing that was given is that FG bisects DB. Well, by bisecting, we labeled that in our picture already. That tells us that DE and EB are congruent. So I could say DE is congruent to EB. And the reason why is because of that word bisects. So we could say a bisector divides a segment into two congruent segments. So now I have a set of sides that are congruent. I have a set of angles that are congruent. I've used both givens. So then I have to look back at my picture and hopefully you remember vertical angles telling us that angles 3 and 4 are congruent. So now I could say angles 3 and 4 are congruent by vertical angles. So then I could say the two triangles are congruent to each other. So our triangles are going to be DEF and triangle GEB. And the reason why is angle side angle. So if I look at what I labeled in my picture, I see the angles that are congruent and the set of sides that are congruent, and I notice that the set of sides is in between the set of angles. Now that I know that both triangles are congruent to each other, I know all of their corresponding parts are congruent, so I know FE and EG are congruent. By CPCTC. So again, this is just a triangle proof in disguise. All right, so let's move on to the next one. So next one says that this is a square, and this is the one in class I said has a lot of different ways of proving it. So the first given says that it's a square, which tells us that I know all the diagonals are congruent. I know that the sides are congruent. I know all the angles are 90 degrees. I know the angles bisect the diagonals bisect the angles. There's a lot that I know, and I could actually do this proof about 5 or 6 different ways. I'm going to do what I think is the most basic and easy way to prove this. So the two triangles that we're talking about are triangle PTQ and triangle STR. So those two triangles have two sides that are congruent, here and here. I know that because in a square, all of the sides are congruent. So this first given is only given, PQRS is a square, tells us that PQ is congruent to SR because in a square we have 4 congruent sides. So I have to say in a square, all sides congruent, something along those lines. Remember, your reasons don't have to match mine exactly as long as they make sense. The other thing I know about a square is that the diagonals bisect each other. That's really a parallelogram trait, but we can use it here because a square is a parallelogram. So I can say that PT is congruent to TR. I can say that ST is congruent to TQ, all because in a square, the diagonals bisect each other. On our way there, so now I have all 3 sides are congruent into 2 triangles. So now what I can say is that triangle PTQ is congruent to triangle STR by side, side, side. Because this given told us that we have 3 congruent sides, 2 from that one bubble. Those are the 2 from lesson 4. Let's take a look at the question from lesson 5. So lesson 5 gave us this rectangle. As soon as I see rectangle, I know it's parallelogram, and I also know that the angles are 90 degrees and all congruent to each other, and I know that the diagonals are congruent. In this picture, I don't see diagonals, so I'm probably going to need the fact that a rectangle has congruent angles to complete this proof. It also tells us that we have a midpoint, so as soon as I see midpoint of SR, I know that these 2 pieces are congruent. And it wants us to prove that PM and MQ are congruent. So again, this is going to be a CPCTC proof. So let's take a look at that first given, because that first given tells us a lot. So I could say PQRS is a rectangle. That's given. Now because it's a rectangle, I can say angle S is congruent to angle R. I know that because in a rectangle, all of the angles are congruent to each other. So I can say that right in my proof. So I could say in a rectangle, helps if I spell rectangle right. In a rectangle, all angles are congruent. The other thing I know about rectangles is because they're parallelograms, the opposite sides are congruent. So I can say PS is congruent to QR because in a rectangle, opposite sides are congruent. The other given says that M is the midpoint of SR. So I got to use that given too. And I already labeled in my picture when I first read that the 2 segments SM and MR are congruent. So I could say SM is congruent to MR because a midpoint divides a segment into two congruent segments. So now that I've done all of that, if I look at my picture, I see side, angle, side right in my picture. So I could say that those two triangles are congruent. So I have triangle PMS is congruent to triangle QMR by side, angle, side. And I know I have an arrow from each of those bubbles that I got to get to there. So now that I know that the two triangles are congruent, I know all of their corresponding pieces, including PM and QM, are congruent by CPCTC. If I was you, I would totally look at lesson number 5's homework proof, because that would probably be the one that I'm going to put on Friday's quiz or something like that. I could even give you the same exact picture with the same exact givens, but ask you to prove, like, angles are congruent or something else in those congruent triangles, still by CPCTC. I could even change midpoint to something else and make it the same picture, but, a little bit different. Hopefully these videos are going to help us. I apologize I haven't been able to make them in a few weeks, but now that we have our stuff all ready, we could keep making these videos, and hopefully they're helping you. All right, best of luck on your proofs, and I'll see you all tomorrow.